Hello everyone. I hope you're all doing well. My name is Astrid and I'm a program manager here at Encode Club. I'm really excited to have you all here today. We're having a great session from Kaiko on Mastering Chainlink Data. I'm just going to take a second now to invite our speakers to the stage. I'll give them a quick introduction. Hi guys, great to have you here. Just for everyone's reference, this is Anastasia, who is the Senior Blockchain Data Product Manager at Kaiko. And we also have Michaël, who is a Senior Quant Product Manager. Thank you so much for being here. It's great to have you.
Thank you.
Thank you.
With that in mind, do you want to potentially share your screen, Anastasia?
Yeah. Do you want us to begin right now or do we wait a bit?
If you want to wait a bit, we could do that, but otherwise we're also welcome to get going right away and people will join as the presentation goes on.
Okay, then let's begin because we have much to say. Do you see my screen?
Yes, I see your screen.
Okay, great. All right, so first, thanks so much for inviting us. So we both are from Kaiko. So Kaiko works with Chainlink now for a while. It's been some years. And I'll explain to you how we work together. So today we wanted to share with you how is it like working with Chainlink from the data provider's perspective, as well as what data do we share on Chainlink, and why is it important to have qualitative data shared on chain and consumed by protocols on the blockchain. Just a few words on Kaiko to begin. So Kaiko has been founded in 2014. So we're an institutional grade market data provider, which means that we provide market data to financial institutions and corporate clients. This data includes both like all types of market data, including trade data, order book data, so prices, volumes, etc., as well as quantitative analytics and indices. So we also provide regulated indices to our customers. And we finally also produce research, which is accessible for free through our newsletters. So this data, we make it available through our own off-chain tools, including REST APIs, CSV files, and our stream services, which is about sharing the data in real time. However, we also make this data available, at least some of it, directly on-chain using Chainlink. And this is what this presentation is about. So Kaiko works two ways with Chainlink. We first act as a node operator, which means that we publish data directly on the blockchain. This data is price data, and we provide this data for today more than 25 pairs, so crypto pairs. So we work with Chainlink this way since 2018, 2019. So we're pretty much one of the first node operators on the Chainlink ecosystem, but we also help other node operators to publish data on chain by providing them also our data. Because basically the data providers that publish the data on chain on Chainlink are generally data aggregators. It's not data providers like Kaiko. So we provide them this data, which they aggregate after and which they re-push on chain on the Chainlink ecosystem. So this is what it looks like on Chainlink side when it comes to the data for a given crypto pair. So OCR nodes, so there is one kind of OCR environment by pair for price data. So this is for the OXT USD pair, and as you can see, you have a set of data providers who are selected by Chainlink. Their number can vary from one pair to the other, depending on the nature of the pair. And as you can see, we have Kaiko here, who publishes data for this specific pair. And now I'll explain to you how it works on the technical front. So who participates in this, in the data generation and consumption process, and really where does the data comes from and goes from in order to go in the end to the data consumer's hands. So in the OCR environment, we have three participants. We have the data providers who act as OCR nodes. OCR, by the way, stands for off-chain reporting nodes. We have Chainlink smart contracts, and we have the data consumers. And we will see how the three are actually related when it comes to the data. So everything begins when Chainlink actually asks for data. So this can be by default. Every 24 hours, the data is requested, or every time the price of a given pair moves by more than X%. Most of the time, I think, is more or less 2% variation of the price of a given pair. And this is only for one pair, whatever this pair is. So once this request has been done, it's actually done to the OCR nodes of a specific pair. And when it comes to Kaiko, we receive this request and we translate it in a language using our internal adapters. So it can automatically give a call to our off-chain APIs and get the best price for this asset at the time that it has been requested. So Michaël, just after, will explain to you what is the best price and how do we ensure that the price we share is actually correct. But before, we need to understand once this price actually is requested from our API, where does it go to end up in the data consumer's hands? So once it's requested from our API, it's then shared in with our OCR node, and in parallel, all the other OCR nodes of this given pair, so all the other data providers that you have seen in the screenshot in the slide before, actually also request the price of this pair. So everyone can actually end up having a price to send to the Chainlink smart contracts. However, what happens once everyone has actually stated their price on the OCR environment is that only one of the OCR nodes is selected to publish the price on chain. So this data provider that is selected is actually randomly selected, and the point of doing this is actually to avoid so every data provider pays gas fees to publish their price on chain, because it can become very expensive, specifically for very volatile crypto pairs. So once one is chosen, they publish the price of each of the data providers on chain, and we still on chain have the trace of who's behind each price. So we have the address of each data provider and the price associated to each one of them for a given moment in time when the price has been requested. So those data end up in Chainlink's smart contracts. So there are several smart contracts, some who are responsible to collect, store, aggregate the latest price that they get from the OCR nodes, and some which are responsible of redistributing the rewards to all the participants, and specifically to data providers who bring the data on chain. And so the data that in the end will be used by data consumers. So once this data is made available on Chainlink smart contracts, then it's aggregated and then it's ready for data consumers to consume. Now, to make the transition between what's the path of the data from off-chain to on-chain, and what data do we push, and why it's important to actually push qualitative data, I'll take the example of how DeFi protocols, and specifically lending protocols like Aave, use the data that they get from Chainlink, and specifically price data. So on lending protocols, you have users of those protocols who deposit crypto assets, so they lend crypto assets and borrow other crypto assets. So on those types of protocols, you can only do over-collateralized loans, which means that you can borrow in value less than what you can actually lend. For your position, so the combination of your debt and deposit to be considered as sustainable. Since every user lends and borrows different assets, the protocol itself needs to value their position in one unit, in this case is the dollar, in order to compare the value of their debt and their deposit at any point in time. So lending protocols are doing this by consuming Chainlinks or oracles in general, crypto prices expressed in USD. And for example, when the price of one asset that has been borrowed by several users actually drops, what happens is that the value expressed in dollars and the relative value of what the debt of some users of this asset is reduced, specifically relatively to what has been deposited by this user. So in the end, sometimes their positions become non-solvent, and so they're considered as being part of a liquidation process. So liquidation means that the user that borrowed assets loses his collateral, and this is very bad, basically, both for the protocol, because liquidators have to repay his debt, and for the user itself, because he loses the money that he has deposited. So now imagine that there is a wrong price, like a way below price than the actual correct price that is published on chain. This will create unjustified liquidations, which can lead to millions of dollars being lost in liquidations due to just one wrong price. And this is just an example of why having qualitative data on-chain sent by oracles is that important, because the data has to be correct, it has to be true, otherwise it has consequences. So the data we publish at Kaiko through the Chainlink environment is our price data, and more specifically what we call our cross-price data. So it relies on a robust methodology which ensures those prices to be outlier resistant. And those data are actually aggregated upon both centralized and decentralized exchanges data, which ensures that Kaiko can actually provide the price of pretty much any asset that exists in USD, and so provide a valuation of any asset on chain. So now I'll let the floor to Michaël, who's going to explain to you what's the methodology that we use to make such robust prices available on chain.
We all good, Michael?
Yeah. Sorry for that. Just showing my screen.
Amazing. That was
So
good.
now I will present you our pricing services product, which is how to find a fair price through a robust aggregation and a real-time liquidity path. So this product is used in almost all our tools for pricing and valuation. So what is the context first? As opposed to traditional finance, where all the assets are traded, listed on a centralized exchange, here crypto assets are traded in a multi-fragmented market. So to give you an idea, in the Kaiko's database, we have listed 2,000 of assets, 6,000 of pairs, and 100 of exchanges. So the goal is to find a fair price of a pair of any pair AB in real time. In Kaiko, we think that a fair price is defined as being an outlier resistant price. What do we mean by that is that we don't want a price to be corrupted by just one, two, or three or few trades. So it is not a smooth price. We don't want our price to just be as smooth as possible, but just as fair, as robust as possible. And this in real time and for any pair. The challenge is that there are very large discrepancies in price, in volume, and in liquidity among all the exchanges, which makes the task of finding a market consensus very difficult. So the solution that we propose is first to find the best price aggregation methodology, and second, to find the optimal liquidity path across all the assets to price the pair AB. So first, let me illustrate the challenge of the large fluctuations. So here I show you the trade price distribution per minute of the BTC USD on some day, on a stress day, which is related to the SVB crisis, during 2 p.m. and 3 p.m. So here you have a box plot, 60 box plots, one for each minute. Clearly, you see that the distributions are very tight most of the time, where the horizontal bar, maybe you can see here, represents the first quartile, the median, and the third quartile. And the whiskers represent the mean and the max of a price at each minute. So clearly here you see how hard it is to find a consensual price. One idea could, for example, to compute the mean at each minute, which are represented here by the red triangles. But clearly you see how far are the means regarding the center of the distributions. And so this could lead to what we call a noisy price, because it's okay if the price moves, if the price fluctuates. You have some trades, that's okay. But you don't want some noisy prices, like, for example, those one, where the center of the distribution is close to 20,000 to 200, and your aggregated price will be $200 above. This is not fair for us. It's not a fair price. And so we need to think about something else. So in statistics, there are usually 2 points of view to find the center of a distribution. I mean, there are others, but mainly 2, either the mean or the median. Maybe you've heard about that the median is more stable, more robust than the mean, and I will illustrate here in this quick video. So suppose that you have a sample. You can think about it as an exchange where you collect some trade prices, okay, at a given time. And what you do is just you compute a mean in red and a median in gray. And you repeat the action. You repeat with another sample, 2, 3, 4, up to 100. And you're stacking all the means and medians, empirical means and empirical medians in this histogram. And then you continue, 1,000, 2,000, 3,000, etc. And then you start seeing this bell curve distribution which are both located, centered to their real value, the real mean. You suppose that the real mean should be there. You suppose that the real median should be there. That's okay. It's two different values. They can be located at two different places. But what I should mention, what I want to highlight here is not the location, but it's the scale. The scale of the distribution is related here to how large the tails are. And clearly you see that the tails of the mean are way larger than the tails of the median. So for those who are familiar with, this is an illustration of the central limit theorem. But what I want to highlight here is what you prefer is an estimator, an aggregator, a methodology where you have small probabilities to get far from the center of the distribution. So here we have the center of the mean. You still have some high probability to go far from it, and that's not a good probability that you want to have on your estimator. In fact, the problem is even more challenging because each price does not have the same weights. The weights are related to the volume, and the volume also fluctuates a lot. So here is the same graph, same pair, same day, but now we're looking at the volume, and just in the y-axis, you have in log scale, logarithmic scale. So you see that the volume can go from near $0 up to $100,000. So again, very hard to find a consensual rate associated to a price in order to find a consensual weighted price. So kind of a challenging task. So there are some methodologies for computing such an estimator, such a price. So given some price and volume observations, here you have some PI, VI. So suppose you have n observations. As we said, a first technique will be just a naive empirical average of the price. You don't take into account the volumes. Here, this is a methodology used by Winter, which is a regulated index provider. And since the mean is not that robust, that stable, they also add some extra outlier management tools in order to robustify this mean, but by adding some other hyperparameters, which is something that we don't want to add too much. Having too much hyperparameters, it's really not something that we want. We prefer to have something that is data-driven, driven by the data. And so that's why usually the state-of-the-art methodologies in finance, at least, will be those two. So you're going to weight your price by the volume. The first and the most maybe famous one is the volume-weighted average price, the VWAP, used by digital asset researcher, like in the FTSE or in the Nasdaq, where you compute a price weighted by its volume. And actually, in those research papers, they also add some other outlier management techniques, but still using again and again some other hyperparameters, sorry. Another point of view is not the average, but the median. Don't take too much care about the formula. It's nothing more than finding the price associated to the volume, associated to the median of the volume, sorry. So here again, some other regulators or some other like CME, you have Bloomberg, you have the Fed Reserve Bank of New York, who are also using that in their research, which is another point of view and usually more stable, more robust than the VWAP. And actually in Kaiko, what we proved mathematically is that all those methodologies suffer from instability and lack of robustness when applied to crypto data. And this is due to the large fluctuation of the price and the volume. In statistics, we say that the distribution of the price and the volume are heavy-tailed. And so this phenomena causes this instability and lack of robustness of such a methods. So that's why in Kaiko, we developed our own methodology called robust weighted median, which is all developed here. It's a public paper, and I will give you the reference at the end, which is based on first a deep statistical study of the data and of the state-of-the-art methodology that I just discussed the slide before. And second, we apply a data transformation well adapted to the crypto data behavior. Also, our estimator should satisfy some desired properties, which is listed in this paper, and which are the following one. First, relevance. Of course, our methodology reflects a price consensus. Timeliness should be reactive to market movement. Manipulation resistance, it costs a lot for a trader to significantly move the price compared to the other methods like the VWAP and VWM, which is more easy to move the price with those methods. Martingale, because it is localized in time, so we can't game the market and predict our estimated price. Verifiability, because it's a transparent method. Very easy to reproduce from some input data. Stability, because we proved very nice theoretical stability properties and which are confirmed by numerical experiments. And finally, parsimony, because we have no parameters to set. So it's a fully data-driven estimator. So now let me illustrate you the behavior of our estimator, RWM, against a VWAP in gray and a VWM in orange during normal conditions. So first on the top, BTC USD, very liquid pair. And here you can this illustrates what just Anastasia said, that sometimes if you use a VWAP, it may happen that you can have almost a 2% deviation from kind of a fair price to center price. And this phenomena, of course, can trigger some very undesired events in finance. So you can have this very big outlier for the VWAP and also this one for the VWM. And the thing goes even worse for less liquid pairs like ETH BTC, the bottom. And what I want to emphasize here is one of our properties. You remember the timeliness should be reactive to market movement. And here you clearly see that our estimator is very reactive because it follows the trend and it follows the regime switching between 12 and 3 p.m. Now, let's take a look to a stress day during the SVB crisis. Still BTC USD. And here you see how noisy are the two methodologies, the VWAP and the VWM prices. And finally, on USDC USD, because you know that one of the main drivers of this crisis was the depeg of USDC. And so very interestingly, how our LWM behave against the two other methodologies during that day. So that was the end of the first part. Find a robust methodology. But now, what if we want to price any pair AB if it's either non-liquid or even unlisted? So this problem can be summarized here in a small graph, in a simple graph, where you have some vertices, the assets, and the edges. We are the connections if a pair is traded or not. Okay. So the first part is to define a liquidity score, which has a financial and mathematical interpretation, and which is very fast to compute. So we developed our own score in order to put a weight on each edge. When the weights are here, it's very easy to find the optimal path. So this is a very simple example, but actually in real life, we have to deal with this graph every second, where you can clearly see here three main clusters which are related to BTC, USDT, and USD. So I'm just finished with my presentation. Just mentioned here the paper that we published, which is here. and also the other references.
Great. So thanks a lot, Michaël, for this very detailed explanation of the underlying methodology Kaiko's robust prices is using. To finish, I'll actually reshare my screen and explain to you now other types of data in addition to the price that can be very, very useful for specifically DeFi protocols to use and to consume through oracles. So prices are very common to find through oracles. It's really like the basic data that is available on chain because it has many, many use cases. It's very much used by lending protocols, by derivatives protocols, like for any type of valuation. However, other data are very useful too, and specifically liquidity data. So data on how much liquidity in the markets there is for any given asset that is available either for lending, borrowing, or any other types of financial activities. Getting the liquidity data directly on chain by DeFi protocols is actually very important for two reasons. First, because in those protocols, specifically lending protocols, the positions, so the debt and collateral positions, are very concentrated in some people's hands. So it's very common that there is only one or two people, so addresses that hold in collateral more than 20 or 50% of one asset's liquidity. So this is very dangerous because if this position fails, it means that it enters a liquidation process. And so it means that there needs to be enough liquidity in the market to back those liquidation processes. And so smart contracts that offer those tokens as collateral and as debt need to have the information on how much liquidity there is in real time in all markets to make sure they don't provide totally illiquid tokens to their users. One example of token that we can cite for this example is the CRV token that I'm sure you have heard of lately. So before August, there was some stories around CRV and its illiquidity and the danger of the liquidations that could be caused based on the latest market trends for this asset. But this is not the only reason why getting liquidity data directly on chain is also important. Another reason is the frequency of flash crashes in crypto. So crypto are known to be volatile, and this volatility, as well as related to many unexpected events, let's say, can lead to market events that can be risky for the ecosystem's participants. And so every DeFi protocol needs to have not only the price of those crypto directly available in their smart contracts, but also the liquidity of those crypto in the markets. And in the beginning, I told you, Kaiko covers all types of markets, both centralized and decentralized exchanges, and we provide both the trading the trade data, the prices, the volumes that are traded in any of those marketplaces, as well as the liquidity data, which means the order books data, the liquidity pools data. And so this data all combined represents what we call liquidity data. So overall, those DeFi protocols end up with an illiquidity risk and potentially a bad debt risk. Bad debt is when a debt is never going to be paid back due to the market conditions and the lack of liquidity that there is in the markets. And so today protocols are not equipped against such risks, and which means that they don't have any tools to to know what is the liquidity of the assets that they make available for their customers. So one solution could be to make such data available directly on chain using oracles. So this data, we have it ourselves, available off-chain only for now, through REST APIs. So it combines data on centralized exchanges, which comes from order books. This data is called market depth data. So it tells you exactly how much volume is available for sell and for buy at different price levels for a given pair of assets. We have this data also available for decentralized exchanges. This data is derived, in the case of decentralized exchanges, directly from the liquidity pools, token reserves. And finally, we have liquidity metrics, comparative between centralized and decentralized exchanges, through our asset metrics APIs, which give an aggregated view of the overall liquidity of any asset that is available in any market. To conclude, we have seen that Kaiko works with Chainlink as a node provider, but also feeds other data providers and node providers with price data. And so we contribute to the Chainlink ecosystem in two ways. The data that we push is based on a robust methodology that is quite innovative and specifically built for the cryptocurrency data and markets. It helps protocols to avoid typically unjustified liquidations due to its quality. And it's even based on a liquidity path to make sure that it's possible to get the price of any cryptocurrency, whether or not it's available in the markets with respect to the USD. Finally, other types of data can be used on-chain by protocols, specifically liquidity data, as I just explained to you. We're now open for questions, if you have any. So yeah, thank you very much.
Thank you so much, guys. That was a great and very insightful presentation. Yeah, just to echo what Anastasia just said, we are now open for questions. If you have any, you can go into the questions tab down on the right, and you can just press ask a new question. It seems like we've got two from Pablo here. So the first question we have is, are these price calculation with robust weighted median publicly recorded on blockchain? Is there a smart contract calculating the RBM, or is the data calculation centralized?
So I'll take this one.
Okay.
So, those data are calculated off-chain. So every time you request those data through the specific API, which gives this data, so it's a Kaiko API, off-chain API, then it computes the data for a given asset with respect to another asset. And thanks to what I described in the beginning, like the whole process of Kaiko publishing data on-chain as an OCR node, it ends up being available on Chainlink this way. So it's computed off-chain, and then it's made available on-chain on Chainlink, and Chainlink afterwards aggregates this data with other price data that they receive from other OCR nodes. And it's actually this result that is made available to the data consumers in the end. So yes, the data calculation is centralized, but it's transparent and robust.
Amazing. So there's actually a follow-up question as well on that. So there's a second question is, how often is the feed data updated on testnets? We found some problems in a project using price data feeds on testnets, i.e. Sapoli and Gorley, due to it not being updated regularly. Anastasia, do you want to take this, or do Michael maybe want to take this one?
I don't know the answer. I don't think Michael knows the answer either. It's clearly an answer to ask Chainlink. But what I know is that depending on the cryptocurrency, the price is updated at different frequencies. So yeah, that's all I know.
Okay, no worries. We did also have a request for someone to share the paper on the robust weighted median. So Michael, actually, everyone, I'll be sending out any resources that come up from today's session, including this paper, in the Discord later on. How about we do that? Apart from that, I wanted to check.
I see a third question.
Yeah,
oh, you see a third question?
On the chat.
On the chat.
It's for Michaël.
Regarding the tail distribution of the price.
So yeah.
Yes, Michael, do you want to take that?
Yeah. So actually, yes, the problem is both the tail distribution of both the price and the volume. As I said, usually the price is weighted by the volume. So you take into account both quantities in your calculation. And so you have to deal with the distribution of the both quantities. And so actually both are heavy-tailed, and that's what creates the large fluctuations of the estimators. So we don't use VWM rather. By the way, maybe most or even all the other data provider competitors use either VWAP or VWM, but we figured out that those methodologies suffer from large fluctuations by mathematical proof, and also that's why we developed our own methodology, the RWM, that we use to price our assets.
And by the way, fun fact, in the beginning, we used to actually compute the VWAPs for such prices, but we have seen that those VWAPs are not efficient, and it has been actually a long process to improve our own data feeds to match Chainlink's and Chainlink's data consumers' requests.
Amazing. Sounds interesting. I want to just have one last call out. Oh, brilliant. More questions. Michael, you mentioned using RWM with unlisted tokens. Do you mind explaining further how this would work, please? I didn't fully understand the graphs in the presentation.
Okay, maybe I can reshare my screen.
Yeah, I think that's a great idea.
Okay. Sorry, I don't have so much time to talk about this because also it's not maybe the main subject of this talk. But here you can see this graph as a map. Like this is I don't know New York. This is San Francisco, and you have some different cities. And so when you use like for example Waze or Google Map, what do you want to minimize is the time. Okay, you also have the distance, which is a quantity that you should which is kind of important. But now we do not have any quantity here. We have to build our own distance. So that's our liquidity score that I don't have time to discuss here. But we have our methodology to define a distance, to define a score between each city, between each edge, between each vertex, which is represented by an asset. Now, once you have defined your score, your distance, you can apply some very effective algorithm, very well-known algorithm to find the optimum path. Like it's the same algorithm used in almost all kind of same application. Google Maps use the same one, for example, to find the best path to go from A to B. This is the first part. So now that using the RWM, my point is that you can compute the RWM between A and USDT, between USDT and BTC, and finally between BTC and B. And if you make a product of these three quantities, you will have the price of AB. Does it answer your question?
I think so.
Well, yeah, we'll let Gregory respond in the chat. Yes, thank you. Beautiful. I saw we had one question in the chat as well. Solomon writes, how do you deal with centralized exchanges inflating their value? In the past, some centralized exchanges were caught reporting fake volumes.
Actually, our methodology is really data-driven. So we take all the data available and try to find the most robust price by have a special data transformation on the volume. Now we don't have, sometimes if we have this information, okay, we can deal with, but usually our methodology is fully data driven and should kind of be okay with this event. Now, if you have a very large fake volume on a very fake price, there is kind of nothing to do. Like we will be, of course, we will give a price that is related to the most of the volume in a given day.
Except if you know that the volume is fake. In this case, we can typically blacklist some exchanges, which I think it's the case.
Yes.
Yeah. Yes. We have another question.
No? Oh, I can see someone typing. Yeah. I'll see if that one comes in. Okay, yeah, there is another question here. We'll start with Hardy first while Pablo is typing. Hardy, it says, for unlisted tokens, do you have dynamic edges?
Actually, we don't. When we compute a graph, this graph is computed online, like in real time. When you make a request, we compute all the graphs, compute all the scores, find the optimal path, and make the product and give you the price. Okay. So what we do is that we build a graph in real time such that you just have listed pairs. You just have pairs with traded volume at that time. Otherwise, this edge, dynamic edges. Oh, sorry. No, I don't know if it answers your question. Yeah. Not sure what you. I have two cents in mind for dynamic edges, so I don't know if it answers your question.
Hardy, do you maybe want to come in the chat and clarify?
But my first answer would be we compute a graph online. So if an asset is not listed or traded, it will be not part of the graph. So it's not an issue for us.
Okay, let's maybe leave that question there for now because I can see there's another one there. And if the person who asked this wants to follow up, we can always do so. Okay. So Pablo has a follow-up to Solomon's question. He asked, you can use different data feeds. For example, what if I want to use the RWM calculated based on decentralized exchange prices instead of centralized exchange? Is that an option?
I can take this one. It's not an option. This price will automatically take the most liquid markets. Here, we mix both centralized and decentralized exchanges. However, if one wants an aggregated price based only on centralized or decentralized exchanges of their choice, then we have other pricing offerings which are made for this. Yeah.
I can also add something that if you want a price from just specific exchanges, you can. And you can, in our product, you can just specify that I want a price on this exchange and this exchange. And our methodology will compute the RWM just on the trades coming from those two exchanges.
So yeah, there is a parameter to specify what you want as exchanges.
Amazing. Okay, we have another question from Hardy. For RWM, do you use time varying distribution or do you use a predefined distribution?
What do you mean by time varying distribution? I mean, this is a really non-parametric estimator. It's really data-driven, so we don't use any predefined distribution. We don't estimate any parameter. Don't know if it answers your question.
I'll let that. I'll let them comment if they want to follow up on that. But I think we're there. Oh, okay. We wrote. I see. Thank you. So I think I'm assuming that means that the question was answered. All right. I want to do one final call out for any more questions from the chat. If you have any burning questions, there we go. We got one. Question: How is the payment to data providers done? Did Chainlink subsidize data providers to provide data, or projects pay directly to data providers for data, or Chainlink serves as intermediary between data providers and projects looking for data? So, is that clear, or does that need clarification?
Yes, it's clear.
You got it? Okay.
Yeah. So when it comes to data providers that push directly the data on chain, so which are OCR nodes, we receive link rewards directly from Chainlink. So it's not the data consumers who pay the data providers. It's Chainlink acting as an intermediary and pays who has participated in bringing the true value of crypto assets on chain. Now, when it comes to the other side, so do you remember I explained to you in the beginning, we work directly with Chainlink, but we also help other data aggregators enrich the price data they have and publish themselves afterwards an aggregated version of the price of several data providers on chain. So with them, we do have enterprise licenses, because it's generally professionals being behind each OCR node.
Okay, amazing. I can see that one last person is, oh no, we've got a couple of people typing. So I'll let those, okay. All right, cool, thanks. I think I want to ask if there's, okay, here we are. The data providers nodes, are they mostly centralized servers like Amazon, Microsoft?
I don't have this information.
Michael, do you know?
Do you?
No.
Okay. Sorry.
Okay. Well, we'll leave that one there. I'm sure that if someone wants to follow up later, you can always ask on Discord, and I might have an answer for you by then. All right. Is there anything else in the chat? Anyone else have a question to ask? All right. It looks like everything is good to go. Okay, thank you. Looks like everything is good to go. Thank you so much, Anastasia and Michael, for being here today. This was a really good presentation. Also, thank you for answering all of the questions today. I want to give a quick shout out to the audience as well. You've been really great at participating and having loads of questions for our hosts today. With that, I think we'll close off today. All of the materials will also be sent off by email and Discord later on. So yeah, cheers to that. And I'll see you for the next session on Monday. Bye, everyone.
Bye.
Bye.